the slides. Yeah, I forgot to record. Thank you for that. And then for the, just to reiterate again, welcome to Hack Sprint session 2. Here are the links to the slides and the README. And if you have one link, you will have the link to the slides link to the README, and the README links to the slides. So yeah, be on the lookout for that. And also for the feedback form, this is a link to the feedback form. We really appreciated lots of people filling in the feedback form last week, and we would hope if that would stay the same as well. So please fill out the feedback form at the end of the workshop to tell us how you thought about the workshop. Yeah, and this is also reiterating on last week. We have a new Hack Discord now, so make sure to join it to keep up to date with everything Hack Sprint related. And also, again, reiterating about projects. So throughout the quarter, you will have an opportunity to create your own app and eventually showcase your own iOS app during week 9's workshop. And the group formation will be released this week on the Hack Discord. Yeah, so last week, we sort of had an introduction to Swift and shown how we can, use Swift to start this really basic iOS app. This week, we will be jumping into some Swift fundamentals of the Swift programming language. And so what this session is basically going to be is you can think of it as a very simple crash course on Swift. And don't worry if you're new to programming, we'll be starting from the beginning. And these are sort of like the topics that we'll be going over today. Okay, yeah, trackpad gaming. And just a note though, so if you are new to programming, because there's just so much topics to cover, we'll be going at a very, very fast pace for someone new. So I think the main idea for today is you don't have to, please don't try to memorize everything. And the main goal of today's workshop is to make sure that we have the knowledge to give substance to what we learned last week, as well as to build the foundation for us to understand more advanced topics in the later sessions. So please you don't have to memorize everything. You just need to know that these things exist and just know at some high level how they work. And yeah, so again, another note on coding along. Because there's just, I'm gonna be going really fast today. So we encourage you to try out the things we cover after a workshop, but we don't recommend coding along, especially today, since I will be typing a lot of code. And the README has all the talking points from the workshop, so you can use those as notes if you want to go back on them. And as always, ask us questions on the Discord in the Hack Sprint questions channel. So you can reach out to us for help, sorry. And again, this might be for people who are new to this session, who didn't come last week. Can I participate if I have a Windows? And unfortunately, because we're Hack Sprint this year, we're doing iOS apps, and iOS apps is restricted to Mac OS only. So if you have a Windows, you will have to look into other ways to get your own Mac device, such as paid services or the UCLA Quick Click equipment lending. And we have here that response time might be impacted by COVID-19, but actually they've been pretty good about responding to people. So I actually put in a request for a MacBook Pro, and I am now off the wait list. So you guys should, if you guys really want to try out iOS development and you don't have a Mac, the Click equipment lending will be very useful for you. Yeah. However, we still welcome you to learn, even if you aren't planning on getting a Mac, because a lot of these concepts are transferable. Oh, and also a note about the chat for this session. I can't really access, I don't really have the chat handy right now, so I'll probably only check it occasionally. Yeah. Okay. Yeah, that being said, after saying all that about Macs and whatnot, you don't actually need a Mac for this session because today we'll only be covering the Swift programming language. And you actually don't need a Mac to run Swift code. If you're on Windows, I highly recommend compiler. And yeah, that's like a really commonly used tool if you want to really quickly run code, is to use an online compiler. What I will be using today, though, is something called Swift Playgrounds, which is a very useful tool that you can just really quickly run Swift on, and it sort of looks like this. You can create your own, like after you download it on the App Store, you can open it and you can create your own playground. So I'm creating my own playground right now. And yeah, you can type whatever code you want and then you can run the code. And Playground provides like really, really convenient tools to make coding in Swift as easy and as accessible as possible. Yeah. Okay, so that's it. Before we get started, just please ask questions if you're confused at any point. Officers and mentors are here to help. So yeah, so just again, also I want to reiterate on last week where we saw like a bit of confusion regarding the name about naming. So when people say iOS mobile development using Swift, like I'm creating an iOS mobile app using Swift, what they actually mean is that they're making apps using the Swift programming language, and Swift is actually just another programming language, just like Python, just like C++, right? So just another programming language, but you may notice that, like, for example, you can't create a iOS app using a language like Python. There isn't an easy way. And so what people mean when when they say that they're developing iOS apps using Swift is that they're using SwiftUI or they're using UIKit. And SwiftUI is a framework. And what a framework is, you can think of it as like a set of tools used to help you and me develop iOS apps using the Swift programming language. So yeah, just a bit of clarification for those who are confused. And so if we go back to last week, where we managed to create like an app, what we see on the left here is actually just Swift code. And normally we won't be able to access this code. Like you notice here on the top line that we imported something called SwiftUI, and that is what allows us to use the tools that other people have written for us to create what you see here displayed on the screen on the right. Yeah, so today's workshop, this session, is all about making sure that you understand what on earth this code means and what it's doing, and making sure that you can build on it and understand more complex Swift concepts, programming concepts, so that you can apply it in future sessions too. Okay, so let's jump into some Swift. Okay, first things first, I want to go over printing. So in Swift, we use print to display something onto the terminal. And if you don't understand what this means, the terminal is sort of like the output of our code that we run. So if I go to Swift Playgrounds and I say it's like print, and then the way print works is you type print, and then inside the parentheses, you can print whatever you want. In this case, I'm gonna print hello world surrounded in quotation marks. And then you can run your code at the bottom right here, and it will, and then you can also click the terminal icon to open the terminal, and you see that Swift actually prints hello world onto the terminal. And I can print more things like, so wait, this is so weird. I'm not used to this keyboard. I could, for example, print start of hack sprint session 2. Okay, and if I run my code again, you'll see that the code prints start of hack sprint session 2 on the right side on the terminal. Okay. Okay, so that's great. Any questions about printing? Okay. Cool. So also, just another note on semicolons. Semicolons are not required in Swift, which means that if you have a semicolon at the end of a statement, it does the same. It really just does nothing. But when you have multiple statements in the same line, then semicolons are required. And what I mean by this is, for example, if I wanted to print, so for example, if you look at these two lines, if I added a semicolon at the end here and I run my code, it really makes no difference whether or not I had the semicolon there or not. But if I wanted to say print something like Dare is cool, then and I try to run my code, then you'll see that Swift Playgrounds is really smart. It knows that what I'm trying to do, and it tells me that consecutive statements on a line must be separated by a semicolon. So I have to add semicolon here, like so, and this will work. Yeah, and you can add one here or not, it doesn't really matter. Okay, so yeah, so general advices, we use semicolons when we have multiple statements in a line, but we don't use semicolons when we have a single statement in the line. And the reason why we're making such a big deal about semicolons is if you come from like another programming language, you may like C++, you'll know that generally semicolons are required in a lot of languages, but here we don't. Yeah. Okay. So without further ado, let's jump into variables and how we can define variables. So variables allow us to store data, keep track of it, and use it later on in code. And in Swift, we use the let and var keywords to declare variables. And we use a let keyword when declaring a variable that will not change. This is often called like a constant. And then we use var when declaring a variable that will change. Okay, so that's sort of syntax for that looks something like this. So we have a var or let keyword here, and then we have the variable name, whatever we want to define, and then we have some value after the equal sign. Okay, so what that looks like is something like this. Let's say I've been recently getting into this show called Our Beloved Summer. So I want to define a variable related to that. So first of all, I have let, which is the keyword. And then the variable name, let's say that I want it to be name. I want to define a name. And then I set it equal to Choyeong, which is the name of the main character in Beloved Summer. Okay. And then I can do whatever I want with this variable now. I can print it and it will print Choyeong at the bottom here. Okay. Also, another thing is I'm going to try comment out this code. What I just did was it's called commenting out code. It means I don't want this code to be here anymore. I don't want to run it, but I still want it to be here.
You don't have to declare the type?
Yeah, we'll get into that later.
Okay.
Yeah. Yeah, so what I'm just going back to comments. Comments are sort of like we want to have sort of this our text here, but we don't want our Swift to treat it as code. And often this is called commenting out code. Yeah. Just to show you that let is for constants, if I try to change name, so I try to change it to another variable like Kokyunsu, then Swift actually doesn't let me. It says that you cannot assign value name because it is a let constant. And if I wanted to do it, I'd have to change it. You'll see that Playgrounds is really smart, and it gives me suggestions on how to change and fix the error. And if I did it now, then if I ran my code, it would print the two names like I expected them to. Okay. Okay, so yeah, what Angela just said is very correct. Usually this is not actually how we declare variables in Swift. And that is because we didn't specify the type. So what are types? Types are what we use to classify different kinds of data. And by different kinds of data, I mean, like some basic types in Swift are like int, which stands for integer, so whole numbers, string, which you can think of as like a sequence of characters. Often this is used to form sentences. And then bool, which is Boolean, which only has true or false, and double, which is sort of like numbers, but you can have decimal points, whereas for integers, you can't have decimal points. So yeah, the way we declare variables now with our new found knowledge of types is we have the variable. The difference is that we have a colon after the variable name, and then we specify the type, whatever type. So it could be int, string, bool, or double after the colon. So what this would look like is I could, let me just comment these out now. I could define some variables. So for example, let's go with a name again. So I'm going to define a name, and it is going to have type string. I want it to have a type string. So, I'm going to call this name Nari. And the way you define a string is you have these quotation marks surrounded by whatever string that you want. So what I've been printing and defining up here are all strings. Okay, and I guess I should also give a little quick introduction on what each type looks like. So I'm going to go back. So these are some examples of what each type value may look like if you are new to these types. So for example, an int would be just a number, so 30, and string is what we've been seeing before. This is what we've seen for the past 10 minutes. So we have the quotation marks and then whatever string of characters you have, and then and then some double, which is I guess this is an error. I should fix it. I'm gonna go fix it right now because I don't want people to get confused. So there should be a double. I made a mistake. And then yeah, so where was I? Oh yeah, I was introducing the examples of different types, and I think I was on Boolean. So Boolean can only have one or two values, true or false. So yeah, in this case, we have true or false here. Okay, so let me go back to Swift Playgrounds, and we can see. Let's define some of these. So for example, for ints, I may want to have age. So for example, if I have an integer, then I could have any number. So I could do like 420. And then for GPA, I have double and 4.20, for example. Nare's GPA is 4.20. And then for Booleans, we can find some variable called gamer, and then it'll be bool, type bool, and we'll set the value to true. Okay, and yeah, so this is how we properly define variables now, and this previous way is like a fake method. So whenever you define variables, please make sure to specify the types, because it is very useful to always specify your types, and it will save your butt in the future. Yeah. Okay. Any questions so far? How's my voice doing? So I'm gonna move on to operators now. What operators are they're just like ways we can manipulate variables to create new ones or to change existing ones. And some examples of operators will include the arithmetic operators on the top here. So there's plus, minus, multiply, and divide, and these work exactly how you would expect them in maths. So you can like add or subtract integers and all that. And then on the second row here are the comparison operators. So the double equal sign will check if two variables are equal, and it will return a Boolean, which is true or false. And this is for not equals. This is for larger, smaller. Again, you could almost as if you're doing math, you're seeing if you're seeing if like two numbers are larger or smaller than each other. And this is very intuitive so far. And here are the logical operators. So these work on Boolean values only. And this is the logical not operator. So and logical and the logical or. And we'll see examples of these later as we go on. Okay. So wait, what? Okay. Okay. So let's see some examples of that. Sorry, I'm very not used to using a Mac. I just got this like yesterday. Okay. And let's see how operators work. So first, let me just define some integers. Okay, so let's define an integer called x, and I'm gonna set its value to something like 8. Okay, and let's define another one called y, and its value is 2. Okay, and then I could define another variable z, who's also int, and we can do, for example, 8 plus 2. And if I try to print z, we'll see that it works exactly how we expect it to, as if you're doing math. 8 plus 2 is 10, and you can do the same for 8 divided by 2, and it'd be 4. Yeah, so this is really intuitive. Yeah, so let's comment this out first. And similar for, fun fact about strings is you can actually concatenate them using the plus operator. So for example, if I defined a string whose name is, which value is nare, so I can say variable fact, and it's of type string, and I could set that equal to name plus, and then some string is cool. And if I printed fact again, it would be nar is cool. Okay, so it's almost as if we're combining the two strings together. Okay, and let's see some other operators for the comparison operators. So if I printed, for example, is age equals to 420, then if we run our code, it would be true. So just as I explained before, it will check if these two on the left and right are equal, and then it will return a Boolean. And in this case, it's true. So if I printed, for example, age is large, oh my goodness, what is it? Okay, age is larger than 20, and I run my code, it would be true too. And if I change this to, for example, 500, it would be false. Okay, and for some examples on logical operators, if I did true, like ended with false, and this would print false because the AND operator only prints true if both sides are true. Okay, so this would be false. Okay, it's a little hard to keep track, so I'm going to comment these out. Okay, that is not what I wanted to do. Comment these out. Okay, and then for the OR operator, we could do false or true. And if we run our code, it would be true because OR only needs one of the values on the left and right to be true, then it will return true. And then we would, for example, the not free would be to just negate everything. So if I did true and false or not true, it would return us a false, because true, not true will be false. And so the whole or expression will be false, and true and false, as we saw above, is false. Okay. So any questions about this? Okay, great. I'm gonna move on. I'm gonna talk a bit about string interpolation. So this is just like a really cool and convenient feature that Swift has. So if I, for example, I had an integer Naruto and like a string, as I shown you before, strings you can concatenate with this plus operator. So this would print Naruto as a very good show. But this is like really inconvenient, sort of, because we have to, you know, let's say we wanted to concatenate a bunch of strings together, then we'd have to have a lot of plus operators, and we gotta keep worrying about like whether or not there's a space here. And so this is like a very, you know, sad representation of like, or sad way to do string concatenation. And a very convenient way that Swift lets us do string concat or like combine strings together is using something called string interpolation. And it is just this backslash or forward slash, and then followed by parentheses. And in the middle, we could add whatever variable we wanted. And yeah, so this is just like a really like the way more convenient method, and will be what we will be using going forward. So yeah, this is the better way. Okay, so we covered, I guess, quite a bit. So I'm gonna go ahead and do a poll. And the way I'm gonna do that is I'm gonna show some code on the screen, and you're gonna have to answer questions related to the code. So if this works, right? Perfect. Okay, so this is control, yes. Okay, so I'm gonna paste this code here. Hello, can I not edit? Hello, Command V. Thank you. Okay, and poll, and I'm going to launch the first poll. Okay, cool. And we're just gonna give like 1 or 2 minutes for this. It's not, it shouldn't take that long. Oh, okay, nice. The first question is very I would say it's quite pointless, but I think it will like get your brains working. Okay, so I'm just gonna give it like 30 more seconds. Also, if you're like, of course, I think this doesn't have to be said, but try not to like copy and paste, like just whenever you see a problem, you just straight up copy and paste the code onto a compiler or Swift playgrounds and try to run it. The whole point of this question is that you're supposed to like use your understanding of Swift to try to see what the result will be. But then if you want to check your answers afterwards, that's fine too. Okay, so I don't think everyone answered, as we have about like 60%, but I'm gonna close the poll in 5, 4, 3, 2, 1. Okay. Okay. Wow, this is so slow. Oh my goodness. Oh my goodness, Asha. Okay. So yeah, so for the first question, I think the majority of you got the correct answer. I think this is the correct answer. Yeah, and if it's not not easy to see, we have pen and pine here as the first string, and then we sub in pineapple, which is apple, and then we sub in pen, and then we sub in another pineapple. So pen, pineapple, pen, pineapple. And then for the second question, we have that actually the majority didn't get the correct answer, but this code will actually result in an error. And this is because Swift is very, very strict with types. So when we declared text here, we told ourselves and Swift that text should only contain a value of type string, and user count should only contain a value of type int. And here we try to set user count in this line. We try to set the value of user count, which is 5, into text, and text should does not a text is of type string, so it cannot hold a value of type int. So this code will actually result in an error. Okay, so just a note for the future that Swift is actually really, really strict with types, and you can't like mix or match any sort of types. Yeah, you have to do something called casting if you want to do that. But yeah, okay, so that's good. Let's move on. So I'm gonna resume the presentation. And we're gonna talk about conditionals. So conditionals are how we can control our programming code to behave differently based on different conditions. And in Swift, we do this using if-else statements. So what it looks like is, it looks like this. If an if-else statement in Swift looks like this, and it actually reads very much like English. So if you start from the beginning, we have the if keyword here. So this is the same. Oh, sorry, that was not supposed to. If some condition is true, then we will run whatever code is inside this curly brace. Else, if that condition is not true, then we will run whatever code is inside this curly brace. So in this case, if we have, by condition, I mean like some Boolean value or some Boolean condition. So for example, if age is larger than or equal to 21, this will become remember from before, this will become a Boolean, so true or false. And if it is if age is larger than or equal to 21, then we will print can drink. Otherwise, we'll print cannot drink. Yeah, so that's that. Also, I'm going to move on and talk about how to do multiple conditions. But before that, does anyone have any questions so far? Okay, well then you can stare at the Paul Eugene face a little longer. So I'm going to talk about if else blocks. So previously in the in the first example, we couldn't really check for multiple conditions. We could only check for one condition. And so if checks in this example checks for 2, but we could add multiple else if statements and check for a lot of conditions. So again, going from the top, this else if else block is actually very similar to how we would read it in English. So first we check the first condition. If that is true, then we will run whatever code is inside the first curly brace. And if it isn't true, then we check if the second condition here is true. And if it is true, then we will run the code in here. And we will also, like after we run the code, we will just ignore everything else. And we will just directly skip to the next step in the execution. Okay, and then So the way it works is that it will keep checking these conditions until it hits one of them. And once it hits one of them, it will execute whatever inside that curly brace corresponding to the condition, and then it will exit straight out. Okay. Yeah, so let's see some examples for that. Where's my Swift playground? Oh, it's here. Okay. Right, so I'm gonna comment this stuff out. Okay. So I think let's build off of what was over here. So I'm gonna set age to like a fairly reasonable number, like for example 20, and we can like build off of the example that we saw in the slides. So if age is larger than or equal to 21, then we want to print can drink. Okay. And also another note from people, again, coming from other programming languages, I did not write a 20 here. Just another note is that in Swift, you can have these parentheses around the condition. And if you think that's easier to read for you, then you can also add that. It doesn't really matter in Swift, but generally, we will be doing them without code parentheses. Okay. And else if, sorry, this is not supposed to do 20, this is 21. Don't want to break the laws now, do I? So else if, why is it not spacing for me? Else if age is equal to 20, then we can print something like can drink in Japan, not in the US, right? Okay, and just to show that you can actually check for more than just two. You can like add as many ElseIf as you want. We can add more statements. So if I did ElseIf, age is equal to 19, then this is actually the legal drinking age. In South Korea, not in the US, or not anywhere else. And we can add another one. This is so annoying. Okay. For example, if age is equal to 18, then this is actually the legal drinking age in Hong Kong. So, and finally, you know, let's say if you're under 18, then you cannot drink. Of course, this is not like anywhere in the world, but yeah. Okay. Although I'm sure you guys have not been following these rules at all, but yeah, this is just some trivia knowledge if you didn't know. Okay, so now if I ran this code, because age is 20, what do you guys think will be printed? Okay, that was weird. I shouldn't have asked that because I can't see the chat, but just drop in the chat, what do you think will be printed if I run the code here? Okay, well, will actually be printed. Let's run the code and find out. It shows that we can actually we can drink in Japan, but not in the US. And that's because our code went down from top to bottom, and it first scans this, tries to check this condition. And we know that this condition actually evaluates to false because 20 is not larger than or equal to 21. So we don't run whatever's in here. And then we try to check this condition, and we see that yes, age is equal to 20. So we print can drink in Japan, not in the US. And then we directly skip out of this. We directly just skip and not execute anything afterwards. And we continue executing here. Okay, so that was conditionals. Are there any questions on conditionals? Okay, if not, then it is time for a break. We could take a quick 10-minute break, and we can come back at, let's say, 6:58. Yeah. Oh my goodness. Okay. And our content. Okay, hello everyone. Welcome back to the second half of the workshop. We're gonna be introducing functions. So functions let us define reusable pieces of code that perform specific pieces of functionality. Oh my goodness! Wait, let me get rid of this. Okay, cool. So before we see what functions are, I'm going to try provide some sort of motivation for why we want functions. Okay, so let's say that we had let's say that I wanted to print um, the fact that I liked all the characters in the show Our Beloved Summer. So I say I like the character Choyoung the most, right? For example, I did this, and then I do the same thing, but for every single all the main cast. So I do this. I do Kook Yunsu, and then I do Kim Ji-young. Actually, nobody really likes Kim Ji-young because he's like the second lead. But yeah, I'll put you in just to do that. And then for example, right? Right. That's okay. I'm actually gonna make it larger a bit. Okay. So that's good and all. So if I run the code, yeah, see, I get the result that I wanted. But if let's say that I want in the middle, I wanted to, I don't like the way this is worded. Instead of I like the character Choyoung the most, I want to say my favorite character is Choyoung. So I have to go back and change everything about this. My favorite character is Choyoung, right? And I have to do the same for every single character. And I have to change it again and again, right? Oops. And okay, you're starting to get a little tired, right? If you were me, I would be already be super tired of this, and then I'd be annoyed that I have to retype everything. But you do it anyways because you like the show. So let's look at me doing it, and if I run the code, it's like, okay, that took a bit, but got the result that I wanted. But then you realize that, oh, actually, I want to include their ages too. They're all 18. I want to do that too. I want to include it too. And that's when you get actually fed up, and you start looking for other ways to make this task a lot easier. So the way we do that is we can functions. So functions let us define reusable pieces of code, and in that case, we saw that we actually had a lot of things that were the same. What we're doing is essentially printing almost the same string, but with the character with the name of the character replaced. And functions let us do that. So, I mean, if you've heard of functions in other programming languages, this is how we define functions in Swift. And there's a lot going on, so so we're gonna break this down one by one. So first of all, we have the func keyword. So this function, func keyword, stands for function, and it tells Swift that, okay, we're gonna start defining a function right now. And then on the one on the left, one to the right, sorry, this is the name of the function. So in this case, we're calling this function add1. And then inside of the parentheses, we have the arguments passed into the function. Arguments to a function is sort of like we're giving the function input. Okay, we're giving it input, and in this case, we're giving it an input called num, and it is of type int. So this is how we specify arguments to our functions. And then here, after the a single arrow, we specify the return type of the function. So not all functions return something, but you can think of a return as the output of the function. So we're giving it in an input, so argument, and then it's doing something inside of the function. It's running a bunch of code, and then it spits out an output. It doesn't always have to spit out an output, but when it does, we have to specify the return type of this function. And then inside of the curly braces is whatever code that gets run inside of the function. And including, and we can also return something. That includes returning something. So here, the return keyword tells us to exit the function, but also output and spit out whatever expression is to the right of it. So in this case, what this function does is it takes in a number, and this number has to be an integer. And all it does is it adds 1 to that number, and then it spits it right back out. Okay, so that's the add 1 function that we have here. Okay. Yeah. So, and when you call the function, all you do is you specify the function name, which is why the function name is important, because you'll be using it to call it, and then parentheses, and you pass in the arguments that you want. So for example, and if I wanted to add 5, add 1 to 5, then I'd have to first I have to specify which argument name that I want to pass it in. And so num here corresponds to this number over here. Here's my pointer. And then after the colon, it will be followed by the value that we actually want to pass in. So the result of this function call will return 6. Okay. All right. So let's see some examples of this. We can do the exact same example in the slides just for a reiteration. Oh, this happened again. My computer no longer works. Something is happening and I don't know what it is. Okay. Oh, that is not what I wanted to do. Okay. Okay. Well, I have no idea what just happened, but it happened again, and I don't know how I fix it again. Okay. So where was I? Yeah. We're gonna be defining the function add 1. And it's going to take in an argument of type int, and it's also going to return. Oh, I know what was happening. I'm like navigating down here, I think. But yeah, it's going to return a variable of type int, and we're going to return number plus 1. So this is exactly as we saw in the slides. Oh, actually, okay, that wasn't the problem, but yeah. This is exactly as we saw in the slides, and you'll notice that we can just do let4. For example, equal to int, and then we're going to call the function, and we're going to pass in 3. And 3 plus 1 will be 4, which is why we're naming this variable 4. And if we run the code, I'm going to get rid of this up here. If we run the code, nothing happens because we didn't print anything, right? So I'm going to print 4. And we'll notice that it actually prints 4. Okay, so that's good. And then we can actually, print directly, so we don't need a return value. So we can just print add 1, number, and 4. Okay, so this will be 5 because 4 has a value 4. And when we pass it into our add 1 function, it will add 1 to 4, which is 5, and it will just return it and print it. So we should expect to see 4 and 5 out here. Okay, so yeah, so this is how, like, from a very basic level, like how you can define functions. And so now if we go back to our original example, we wanted to print our favorite character as well as their age. We can define a function, something like print favorite, and then their name is, we want to pass in their name, which is of type string, and then their age, which is of type int. And because we're not returning anything, we don't actually need whatever return type. We can just directly have our braces here. And then I might want to just, no, actually, I think I should just leave it bigger. Okay, so inside of our function, what we do is we want to print our favorite character. So remember that the common thing, that what all of these strings had in common was my favorite character is, and then followed by the character name. So I can print my favorite character is, and then we can use string interpolation to add the variable name in here. So yeah, so this is the name that we pass in up here. Okay, and we can do the same for age, who is of age, or who is, and then we can again use string interpolation, who is age years old. So something I want to mention is that string interpolation actually doesn't really care that much about the types. It will automatically convert all the types for you. So here, what I've named is of type string, and this is fine, right? Because we're putting a string inside of a string. But here we have age, which is of type int, and we're putting an int, which is of type into a string. Putting an int into a string, which is technically not allowed. But what this string interpolation thing does is it's very smart, and under the hood, it will convert all the types back into the string. It will convert this age into a type string, and then it will put it in. It will slot it into the string. So yeah, that's also another reason why it's very convenient to use string interpolation. Yeah, and you'll see it used a lot in the future and out in the wild. Okay, so now that we have this function, we can go ahead and call it. So we can do print favorite name equals to Choyoung. Let's start with the first character and then age 18. So when we call this function, we should expect it to print my favorite character is Choyoung, who is 18 years old. Okay, and let me comment this function out. Okay, so we're focusing on this now. So, and I could do this again and again for all my favorite characters. So age 18. And we can also again repeat this for all of the characters up here. And you see that this is a much better way of doing things, because if we wanted to change our format, all we need to do is change it inside the function. And the callers of the function out here don't need to worry about what all the details of how we actually print it or how we actually implement the printing itself. All they need to worry about is providing an input, and then they will get an output. Okay, so that's from a very basic level what functions are one of the good uses of functions. There are many more reasons why we use functions, but I won't get into that today. Okay, so some of you may be wondering, okay, this is kind of annoying. Why do I have to have the word name here and an age? Okay, especially if you came from another programming language, you maybe just be familiar with just doing this. And then 18, and it just works. We don't need to like specify a name here and whatnot. You'll see if we do this here, Swift actually gives us an error, missing the argument labels. So I wonder if I can like make this bigger. Okay, yeah, we're missing an argument label, and some of you may be thinking that this is very inconvenient. I don't want to type this up all the time, and it is true. So on one hand, it's much more clear to know which variable which argument you're passing in and to label your arguments. But Swift actually provides you with several ways of passing in arguments. And this stems from the concept of internal and external parameters. So I'm going to actually put it here. So we have really here. So internal and external parameters. Why did it just like tab it? I don't know. No idea. Parameters. Okay, so so there is the notion of an external internal parameter, and external parameters means the parameter name that the caller of the function is aware of, and internal parameter refers to what the function itself is aware of. So actually, I could copy and paste this function just to demonstrate what I mean. I could copy and paste this function and add at the beginning of the name argument, I could add a space, and then I could just add another name. So for example, character. Okay, and this is actually allowed. And what we just did was we stated that we wanted character to be the external parameter and the name to be the internal parameter. Okay, so now when we call the function, I have to comment this out. I have to comment all of this out. So now when we call the function, we do character instead. We do character instead. And we do age 18. Okay, so this is the same. So when we print the code, we see that this still works. This works. Okay, so what we did was we said that I want whoever is calling the function to use this name as the argument label. But then inside the function, I want to use this name as the argument label. And this is very useful for several reasons. One of the reasons, as you can see here, it's actually a lot more readable. So if you see here, like print favorite, it used to be print favorite name, Choyoung age 18, but now you can read it as print favorite character, Choyoung age 18, which makes a lot more sense, at least to me. Okay, and in fact, Swift also lets you completely remove the need for external parameter names. So if I copy and paste this again here, and I instead of adding like another name here, if I just added an underscore, this means that I don't want to have an external name, and whoever is calling the function doesn't need to have an external argument label. So I can do the same thing for age. I can add a semicolon in the space. And now when I call the function, I can do the same thing as maybe a lot of people are familiar with. If you've coded before, you can just pass in Choyoung like so, and age 18. And if you run the code, oh wait, sorry, I shouldn't have done that. I was looking at above. And if you run the code, it just works, right? So that is sort of internal and external parameters. And one of like and this is like a really good feature, I think, that Swift has. And it allows for like much more readable code, especially when the external parameter makes a lot more sense outside the function, but doesn't make a lot of sense inside the function. And when the internal parameter doesn't make much sense outside the function, but makes a lot of sense inside the function. And to demonstrate this, I can, for example, I'll comment this out. I could make some function like, this probably exists, but I can make some function like find highest common factor, okay? And, it will, like, people will commonly write it as like number1 int and num2 int. Num1, num2 is just number1, number2. And we want to find the highest common factor between these, and it's going to return the type int. And because we're bad at math, we return 1 for all, because that is apparently the highest common factor that we can find, okay? And when we call the function, it was highest common factor, and we will do like num, 18 and num 36, okay? But for us, the callers of this function, num1 and num2 don't really mean anything. It only means something to the people in here. And what we can actually do is Swift actually reserves some keywords like in and at and for. I'm going to use, I'm not sure if these are actually keywords, but for example, we could define parameters that make much more sense on the outside. For example, I can add a for here as the external parameter, and for the second external parameter. So when we call this function, instead of num1 and num2, we can just say find highest common factor for 18 and 36. And it's exactly the same thing as what we had before. But now when we run the code and when we're writing the code, it makes so much more sense to just say, I am finding the highest common factor for 18 and 36. Yeah. And yeah, so that's internal and external parameters. Generally, I think stylistically wise, we'll always be using, we won't be using, I think, this form, but we'll probably be using more of like the above form here. Yeah. actually don't really, not too sure about. I think it's quite, it's just a lot more clearer to specifically state which parameter you are passing your argument in as. So yeah, so that's internal, external parameters. Do you have any questions? I went through quite a lot. So yeah, I'm gonna check the chat. Yeah, okay, I see like the most questions have been answered. Yeah, and if you find this confusing, again, it just takes like more time to look at and practice, because usually like many languages don't let you have this feature. So yeah, it's something new learned today, then I'll be happy. Okay. Okay, so now that we've covered functions, let's do another poll. Yeah, so this poll is going to be a very similar format as before. I'm going to launch the poll. Where okay, launch. Okay, I didn't want to share results. Wait. Okay, poll 2, launch. Okay, cool. And the code is going to be right here. Cool. Yeah. And if you can't see, yeah, let me know if there's any problems with like seeing the screen or the polls. I'm gonna turn off this. Again, I'm probably gonna give like 1 or 2 minutes for this poll. We're doing quite good on time anyways, I think. Okay, let's give it like around 20 more seconds. Okay, 5, 4, 3, 2, 1, and end poll. Okay, I think I could share the results this time. I forgot to share it last time. Okay, so yeah, most of you guys got the first question correct. And this was a pretty straightforward question. As always, we're checking from, wait. Okay, that did not sound good, but let me know if my audio is cutting out or anything. But score is 40, so we'll first check the first condition. 40 is not larger than 50, so we go down and we check and we succeed in the second condition, so we print you got the second prize. Okay, the second question is actually a trick question, but the majority of you did get it correct, and the answer is function used external parameter name instead of internal parameter name, and the reason for that is if you see here, we declared inside our function we declared width and length as the internal parameter name, so we must width and length inside the function. We cannot use W and L. Okay, and if that is something I didn't mention, then that is probably on me too. Okay, and for the option passed into int as argument when function expected double, actually that was sort of like a trap answer. And the reason why is because even though it's actually this is like technically doing the wrong thing, like we shouldn't be passing, we should be more specific and having 0.0 and 3.0 and 4.0. But what Swift does under the hood, because int and doubles are so similar, it treats 3 as a double. It treats 3 as 3.0. It treats 4 as this 4 here as 4.0. And sort of, this is sort of like an unknown, this is sort of like an unknown thing that we, like you have to like encounter this to actually know it. No one will actually tell you that this is a thing. So yeah, you just know that in like int and doubles, like if you don't specify something, and oftentimes they can be what is called coerced into the other type. Yeah, just a little bit of extra knowledge. And I see a question here about what is W and L inside the function. W and L is supposed to be like the width and length, but here they don't actually make sense. This will return an error. So W and L don't actually exist in this function. We cannot use W and L. We have to use width and length. Does that answer your question? Yeah. Yeah, no problem. These are good questions. I like the fact that some of my trap options in this poll and the previous poll are getting people. It means that it makes me happy. Okay. Yeah, so okay. Hopefully my audio also didn't mess up. I'm hearing this noise on my earpods and I don't like, it makes me like panic inside every time. But yeah, let's move on. So we're gonna dive into another topic. It's called optionals. And this may be a new topic for a lot of you, but let's try to break this down. So sometimes we want a value to represent the absence of a value. And this is often called the nil value in Swift. And if you've coded in other languages like JavaScript, that's called null, but in Swift it's called nil. And just all it represents is there is no value. Yeah, it's a value that represents that there is no value. But however, a nil value is sometimes unsafe. So if you've coded in other languages, if you've tried to access the value of a null in JavaScript, or you've tried to in Python or in other languages, you'll know that the language will crash, like your program will crash, and like they'll throw you an error, and it's like, yeah, bad boy. But Swift doesn't like to be unsafe. Okay, Swift really likes to be safe. I think that's something that we've seen previously, and so Swift introduced something called optional values to force programmers to code in a safe way. We still want nils. Nils are a good value because it represents the absence of value, and sometimes we do need to represent such a value. And so nil is necessary, but we don't want programmers to use nil value in an unsafe way, so they introduce optionals. Okay, so optionals is another type, just another type of value, just as string or ints or bool is also a type. And if a value is an optional, it means that it either has a value or it has the nil value. Okay, and a common analogy is you can think of it as that is used as Schrodinger's cat. So if you have a cat inside a box, and we don't know if the cat inside the box is dead or alive until we open the box, and that is sort of an optional. Everything is inside a box, and it either has a value in it or it has a nil value, but we don't know until we actually open it. Okay, and the way we define optionals in Swift is to add a question mark at the end of a type of a variable to declare it as an optional. And it looks like this. So a variable, it's the same thing as declaring an integer almost, but the difference is we have a question mark at the end. And that just means that this optional number could have a number, or it could have the nil value. And in the line straight after, we set it to the value nil. And we can do that if it was a type int question mark, but we can't do that if it was type int. And yeah, let's see let's just try this example in the playground. That is not the playground. Okay, I'm here. And if I cannot type again. Wonderful. Let me see. Generally, like clicking around and whatnot tends to work. So yeah, okay, cool. Going back to the example on the slide, so if I had an optional int and it's a type int question mark, let's do string actually. So a string question mark, and I set it to the value nil, or if I set it to the value nare, for example, okay, and I realize I'm going to rename this a string. Oh, what just happened? I don't know what just happened, but my laptop froze. Okay, cool. Okay, nothing happened. Cool. I'm sorry about these technical issues, but we'll try to work through this and look into optionals. So I'm gonna rename this to optional string. And notice that I can now set this optional string to nil. And if I run my code, nothing happens, but it successfully runs. But now if I change this back to a string, you'll notice that Swift actually gives me an error. It says nil cannot be assigned to type string. That is relates to what I was talking about before. Nil can only be assigned to a value of type optional. And that is the reason why we do that is to force programmers to be safe about it. So whenever we're dealing with an optional, we have to deal with the fact that it could be a nil value. Okay. Yeah. So the question now is, how do we use this optional? If I try to print optional string, it might give me an error. Or if I try to print it, it gives me nil. I think that's because, but usually, okay. Oh, it's because print doesn't. Okay, so if I try to, for example, let's make another example. If I try to make a fact again, and I had it's of type string, and I said, and I tried to use the optional string, so optional nare is cool. If I try to do that, it should give me an error. If it doesn't, then I'll be very confused. Yeah. What? It doesn't do that? Okay. Okay, this is I'm struggling to understand why. But when we call an optional, what is supposed to happen is that we are not unable to access the variable inside of the optional. So we are unable technically right now to access the value inside of optional string. We have to do special steps to be able to access it. So maybe if I just straight up did optional string, it wouldn't let me do that. Okay, this makes more sense. I think this and this, the interpolation and print are just so powerful that they automatically do everything for us. But here, if I just plainly try to assign an optional string, a type optional string into a string, it will not let me because, as mentioned before, they're different types, and Swift is really strict about different types. So yeah, and Swift actually tells us that a value of optional type string question mark must be unwrapped to a value of type string. So I'm going to talk about how to unwrap this value, because there are actually different ways to unwrap an optional in Swift. And there are actually three main ways to do so. The first way is to use the if-let syntax to unwrap the optional. So what this would look like, well, you'll see examples of this later, but just know that right now this syntax is quite safe. And the second option is to provide a default value using the question mark operator. Again, this operator is just like the operators that I covered before, but this just does a different thing. Yeah, and this is called the null coalescing operator. So this is also quite safe to use. And the option 3 is forcefully unwrapping the value using the exclamation mark operator. And this is quite unsafe. So this is what we don't want. This is like we should use option 3 with a little bit of caution. But I will be going over every single one right now. Okay, so to preface some of this, let's get rid of this. I'm gonna define a function. Okay, I'm gonna define a function called getGrade, and all we want to do is getGrade will take in a score of type in question mark, and it will return a string, which is the grade. So it'll take in a score and return whatever grade that score deserves. And if we try to just directly check, so if I wanted to say score is larger than or equal to 90, then that is an A. So we return A. Else if score is larger than or equal to 80, then return a B. Else if let's just end for now. So let's say that everything else is a C. Okay, and so no matter what score you get, even if you get a 0, you get a C. And right now, if we try to run the function, or at least Swift already, yeah, and expected type for function. Oh, I missed this. Okay, so it should be of type string. Yeah. Okay, so Eugene posted something that I was trying to get at that I just discovered, I guess, just now, that string interpolation actually like does all of it is so powerful that it does all of the optional stuff that I was trying to show wouldn't work, and it just takes care of that for me. So yeah, that's actually something that I learned today. So yeah. Yeah, so if you try to run the function, Swift actually, you see, has an error. A value of optional type int question mark must be unwrapped to a value of type int. So we can't use it. And we saw that previously with the optional string. We have to actually unwrap it. So how do I get rid of this? I don't want to look at you. Okay, so if I copy and paste this, I have to unwrap score first. So I don't want to use score for now. I use the if let syntax. So let's use option 1. So if I do if let, and then after let, I can just define a variable called unwrap score, and it will be the unwrapped value of whatever I was trying to unwrap. So I set it equal to score. Then I'm going to paste this, and then else I'm going to do something else. So what this if let syntax does is it does two things. Okay, the first thing that it does is it first checks if nil, if my score in here is of type, it is a nil value. If it is a nil value, then the entire statement will return false. This will return false, and then so we go down and we execute whatever's inside the else statement. So if it is a nil statement, we will execute whatever is inside here. And in this case, we don't want to return a C. We want to, or any grade. We just want to, I want to return something called return like a grade NG, which stands for no grade, no grade. And that's because the student obviously didn't take the exam. And their score is nil, so nothing. They don't have a score. They didn't take the exam, so they don't have a grade. Okay. However, if score had a value, for example, like 3, it had a value of maybe 100, then this statement will return true, and then it will assign unwrapped score. It will assign 100 to unwrapped score. So unwrapped score is now something of type integer, and we can use it as if it was something of type integer and it was a value inside of score. So we should replace everything with unwrapped score. And just for demonstration purposes, I can actually print unwrapped score in here. Unwrapped score, unwrapped score, okay. Okay, so now if we run our function, for example, get grade, and score was, for example, 18. Let's have a better score. No one wants 18. I got too used to typing 18. And I run my code. We see that unwrapped score has in unwrapped to 95. Oh, I should print this too. And our grade was A. Because unwrapped score is 95, we checked this condition and we returned A. So just to reiterate again, unwrapped score is the actual value inside of score if it does contain a value. If it doesn't contain a value, then we don't deal with any unwrapped score or nothing, and then we just directly go to this case over here. So that's the first method. Any questions about this method? Okay. Oh, and just to demonstrate again, if I passed in nil in here, then it would actually, yeah, okay. Isaac was ahead of the curve. Yeah, it will, if I pass in a nil here, what it does is this if let entirely will check that, oh, you have type nil, and so we execute whatever's inside the else statement, and then we return no grade. Okay, so that's the first type. And then, so for the second method was providing a default value. Okay, so I'm going to, we might copy and paste this comment and then paste it at the bottom. Okay, so what we want is a default value. So right now, we have, we want to use this operator. And what this operator does is it provides a default value if it doesn't have a value, if the score doesn't have a value. And the way we do it is we define a new variable. So we define let unwrap score. It is of type int, and we let it equal to score if it has a value. If it doesn't have a value, we give it another value, some value like -1, okay? And oh, this is supposed to be a type integer, so -1. And then here in our function now, we don't check if we don't check using the if let. We check if unwrapped score is not equal to -1. If unwrapped score is not equal to -1, then score does have a value, so we continue with everything we have here. Else, it means that unwrapped score is -1. That means score doesn't have a value. So we will print no grade. Okay, so we should get the same result here. So I'm going to try 94 or something. And if we run the function, we get an A. And if we ran the function with nil instead, we would get no grade again. So yeah, just to reiterate again, what goes after the null coalescing operator is the default value of whatever you want unwrapped score to have if score contained the nil value. Okay. Yeah, so any questions about that? No. Okay, so let's go over the third method of unwrapping. So I'm going to go ahead and copy and then comment out and then paste. Okay, so the third method is forcefully unwrapping it. So what you can actually do with optionals is you can directly, let me get rid of this. You can directly check if where can I find the slides for this workshop? The slides for this workshop are in the README, and I think a mentor should paste one for you. Yeah. Okay. So what you can actually do with optionals is you can actually check. You can directly check if it is of type nil. So first, I will check if it is a nil, not type nil. If the value is a nil. And if it isn't a nil, then we know for sure that score doesn't have a type nil. So we can then directly check. We can then directly use score. So if score is equal to 90, I'm going to copy and paste all of this actually, and score. And this looks very similar to our old code, return ng, except now we should add a exclamation mark at the end of score. And the reason why we do this is because, as we saw before, if we directly try to use score, then it says that we have to unwrap it first. It says we have to unwrap it first. So yeah, let me get rid of this. And the reason why, so what this exclamation mark does is it just forcefully unwraps it. What we're doing basically is telling Swift that I know what I'm doing. I know 100%, I am 100% sure that score is not going to be a nil if I unwrap it. So I can use it as if it was an integer. So let me use score, please, as if it was an integer, and trust me on this one. So that's an exclamation mark. That's what this exclamation mark does. And in this case, we can be pretty sure ourselves that we can trust ourselves because we checked if score was nil here. If score was nil here, if score was a nil, then we would return empty grade and we wouldn't be accessing it. But generally, as you may have just saw, this score exclamation mark sort of relies on us being good programmers and checking for it beforehand, rather than the previous methods where Swift actually forces us to use this. Otherwise, we won't be able to, forces us to unwrap it. Otherwise, we won't be able to use it. Okay. And yeah, so just to see how this works, if I run the code with nil, the nil value, it would return no grade. And that is because we've checked that score is nil, and so we return no grade. Okay. And if I return 90, scores are getting lower and lower. If I did 90, we would still get an A. Okay. So yeah, so that's optionals. Okay. Any questions about optionals as a whole? Okay, if not, then I will launch another poll. This is the third and last poll of this session. And then we will, this is a very quick poll. So I'll give everyone maybe a minute. Yeah, a minute starting now. Okay. We are also, wait. Oh my goodness. What is happening? Okay. All right, okay, sorry. Yeah, a minute starting now. The responses, let me share the results. So most of you got it correct. The answer is no result, and the reason why is because remember what the nil coalescing operator does is whenever this value on the left here is nil, then it will take this value on the right and use this value instead as a default value, and so it will assign this to string. Okay, so this is actually valid code, and the output is no result. Okay, now we can move on to structs. I'm sorry that
I was so like I couldn't like really like it's really hard to notify me of this stuff, and with all the technical difficulties that's happening this time. But yeah, let's move on with structs. So let's say that I had to group related data together. So for example, if I wanted to find these three variables, and although they're all kind of related, but right now they're just separate variables. So they're just like floating around in our code. And this is fine at first, because we can kind of keep track of it. They're just 3 lines. But what if we wanted to add more people? Let's say for everyone in the drama. So like this would be what we would do, and it's a lot more complicated and a lot more lines of code, and it's just so many more variables to keep track of. So I'm gonna minimize this code here and see what we can actually do with this, and see what we can do with to make it better. So what do we notice in common with all 3 of these variables is that everyone has a name, an age, and occupation. So what if I try to define this notion of a person, and every person has a name, an age, and occupation? Then our sort of 3 chunks of code could look like this. We have a person 1, and its name is Choi-Young and age 18, and we do the same for the other 2. And well, this is nice and all, but this is not really Swift code, right? So let's see how we could actually do that in Swift. And the way we do that in Swift is defining a struct. So what we see here on the screen right now is how we can define a struct. So there's, if we see on the left, there is a struct keyword, and and to the right of that is whatever name of the struct that we want to define. So in this case, going with the previous slide, we named it a person. And inside of the curly braces are sort of what we call the properties of the struct. And again, going from previously, we noticed that every person has a name, age, and occupation. So we would like it to have, we would like for every person to automatically have these defined. So this is our predefined notion of person in Swift. And then you can create a person. Notice that this person now is a type. Now that we've defined a struct, we can now pass it, like use it as just as any other type. And we can create a variable called Choi-Young, and their name is, we can pass in as almost as if we were calling a function. So on the right here, the quote unquote function is the name of the class, and then in the parentheses we can pass in name, Choi-Young, age 18, and occupation artist. And this would be the exact same thing as us constructing this object over here. Okay, this is exactly what we're doing. And after we've constructed this variable, this Choi-Young person, we can then use each and access each property using the name, using the dot operator, sorry. And so for example, Choi-Young.name will print Choi-Young. Yeah. And then aside from properties, we can also define what we call struct methods. So these are called methods. It's basically just a function inside of the struct. So for example, way to sort of explain this is we want every person to be able to introduce themselves. So they have some sort of functionality called introduce, and we want them to be able to introduce themselves. And in this function, it's a very simple function. It doesn't take any arguments, doesn't return anything. All it does is print, hello, my name is name. And this name here, you see that we don't actually define anywhere in our function, but it's up here. And inside any function, we are able to use, inside of any method inside of a struct, we are able to use its properties. Sorry, I'm a little like confused by the things that have been happening. But yeah, and the way you would use this method is using the function. You're able to use this method is again using the dot operator, almost as if we're calling a function. And then, so for example, if we did choyoung.introduce with the parentheses, it would print, hello, my name is Choyoung. And this is a GIF of him actually doing it. Okay, so going really speed, it looks like we've seen this before. So last week, we saw that we could style our views in SwiftUI using view modifiers, so view.modifier. So example of this is, text my app, and then we can make it bold. We can make the text bold. And this is very similar sort of syntax of what we just saw with structs. So we could define a struct, and we call text. It is a text struct. And then we could call a method within the text called bold, which would bold the text. And so this is sort of, I guess, trying to link what we just learned here with structs to things that we can do in SwiftUI and what is actually happening. So in SwiftUI, a text view is actually just a struct. And whenever we do .bold, all we're doing is calling the struct method for that particular view. Okay, so yeah, I'm gonna go. I thought I'd have to go into objects and classes, but we won't have time for that. And I just want to say a quick note that this is not actually the end. So we've covered with many technical difficulties, we've covered some of the basics of Swift, but there are many things that we have left out because we just didn't have the time to. And in the future sessions, we will be covering some of these topics like arrays, dictionaries, closures, inheritance, maybe protocols. So please stick around for that. And also feel free to, with the knowledge that you've learned today, you might be able to be well equipped to understand these more complicated concepts. And yeah, I also had an activity, but you can read this on your own time. It's like 8 o'clock now, so this is just in time for our ending. Sorry today that there were so many technical difficulties. We'll definitely reflect on this in the future session so that this doesn't happen again. And remember to fill out our feedback form and be on the lookout for information about the next session. So yeah, thank you for coming. We can end the recording now.